Hello friends, today we're continuing our study of geometry, and this lesson is going to build on lesson 25. So if you want to go back and review that, but in lesson 25, we talked about the side-side-side congruence postulate. This is the idea that if we have two triangles and we know that the corresponding sides are congruent, then we know that the triangles are congruent, right? And then that's tied in with this idea also that if the triangles are congruent, then all the corresponding parts are congruent. So in this case, right, we looked at triangle MEH and triangle, so MEH, so M corresponds with A, so AIT, right, or A, so we did MHE, ATI is what we have down here because we know that the corresponding sides are congruent. Remember, the order matters. The order that we put these things in when we're writing the congruence statement matter because we want the corresponding vertices to match up. Okay, now there's another way also of proving that triangles are congruent, and that is known as the side angle side congruence postulate. Okay, so what this means is that if I have two sides, two pairs of corresponding sides, so like GE and MT, right, and then TR and GO, if those are congruent. Also, if the included angle is congruent. So you can think of it this way, like if this angle is congruent to this angle, whatever this angle is, it locks this third side in place. Right? If this angle is going to get bigger or smaller, that means this third side is going to have to get longer or shorter. But if this angle is the same as this angle, that means that this side has to be the same as this side. All right, we're not really proving that, we're just stating it because it makes sense. So that means that if we know this, that these two sides are congruent, right? So side, so it's really side angle side. I can even rearrange this to get it that way. Let's see. So we put it into the right order. There we go. So now side, angle, side, it's the included. This means that our two triangles are congruent. So triangle, let's say GEO is congruent to triangle. Now what corresponds with G? It's going to be T. And then E, it's like the other end of the short side, right? So ER. Those two triangles are congruent. How do we know? The side angle side congruence postulate. Now, what if, though, on the other hand, we have something like this? We have these two sides and then this angle over here. Well, if we know that angle T is congruent to angle I, we could say from the drawing, like, oh, well, they look like they're congruent. But the thing is, we need to be able to know for sure. But watch this. This triangle also, right, this version, so let me give it just a little bit different notation. So E prime, H prime, I prime. So it's like a kind of a copy, right? So secondary points. They're not the same as E, H, and I. These are E prime, H prime, and H, I prime, sort of this copy. This triangle, all three of these angles are congruent. EI, E prime, I prime, and MT are all congruent. And E prime, H prime, MA, and EH are all congruent as well. So what happened? So if this outside angle is congruent, then we don't know that the triangles are congruent because it could be in this orientation, like this third side over here could be here, or it could be here. In either case, these angles are congruent, and we can even kind of prove it if I take this and I slide it over the other one. It's reorienting itself automatically, but those angles are pretty much congruent, and so that means that third side is not that these two triangles are not congruent, that we can't tell if it's side angle. Whole idea again is that the angle here has to be the included angle between the two congruent sides. So side angle side, this angle has to be the included angle. All right, so now let's take a look at some situations. Here's a situation where we've got two triangles. Do we know that these two are congruent? The answer is yes. How do we know? Well, we've got this side is congruent to this side is congruent to this side, so I need the included angles. But remember, these in the middle, these are vertical angles. So I know those vertical angles are congruent. So that's side angle side. So I know those two triangles are congruent. So this is how you're going to see things. You're given a situation, and then based on information, you can figure out that you've got congruent sides, or you can figure out that you've got some angles that are congruent to each other. Here's another example. In this case, we've still got the vertical angles. Those are congruent, but here the angle is outside of the two sides, right? So this isn't side angle side, it's angle side side, and you can figure out what that spells. And that doesn't work. It's not appropriate. So don't do it. As long as the angle is outside, it's not the included angle, and it doesn't work. So here we don't know whether they're congruent or not. And then here, in this case, it's the same information we had before, except that we're adding the information that these two sides are parallel. Okay, well, if those two angles are parallel, that means that I've got transversals. And when I have transversals, I know that alternate interior angles are congruent. So this angle is congruent to this angle. Now that's the included angle between the two congruent sides. And so in this case, I can use the side angle side postulate to prove that those two triangles are congruent. So it's a lot of application. And then what you could do, so this could be put into a proof format, right? Given the information here, how do you know they're congruent? Well, you can say the sides are congruent. That's part of the given information. Then you say this side is parallel to this side. That's part of the given information as well. Based on that, you know that you've got, congruent angles because they're an alternate interior. These would be like the steps and giving you some of the reasons. And then once you've got side angle side, then you can say the triangles are congruent. How do you know? Side angle side congruence postulate. So lots of study of triangles in geometry because triangles are the foundational shape, and also lots of application, and so lots of opportunities for practicing things like proofs. I know they're not necessarily that fun, especially when you're first learning them, but there is so much beauty there. And it's one of the best ways to train the mind in logical thinking. So thanks for watching. Don't forget to like, subscribe, and share.